Thank you very much for having me today. I'm delighted to be here. My name is Juliette Fanjat, and I'm currently a scientific project manager at the French Center for Education Studies, which is Cnesco in French. I'm here today to talk to you about some of the work I did for my master thesis. This work involved a lot of technical didactic considerations and statistical analysis. I won't elaborate here and will instead focus on what motivated the study alongside one of the major results that came out of this work. In 2019, France participated for the second time in the TEAM survey, which seeks to measure the performance in mathematics and science of pupils in the fourth year of compulsory education, which is equivalent to the French CM1. When the results came out in 2020, the low scores obtained by French pupils in mathematics were evident. France ranked last in the European Union and second to last among the OECD countries. Several explanations were put forward to account for these poor performances. So first, we have a socioeconomic approach. Cnesco's analysis shows that the French scores were not a result of an overrepresentation of economically disadvantaged pupils in France relative to the other OECD countries. In other words, France's poor performances are not explained by the overall socioeconomic status of French pupils. Another approach is to focus on the mathematics studied by French pupils in class. One way of understanding this is to study the official instructions. Perhaps the poor results of French pupils can be explained by the fact that the prescribed curriculum does not give them the necessary tools to succeed. While this approach is promising, it overlooks the distance that exists between the prescribed curriculum and the real curriculum, between what the official instructions recommend and what happens in the classroom. In other words, such an approach overlooks the existence of content that is included in the expectations for the end of CM1 and yet underachieved by French pupils. One example is the theme of data representation. French pupils first tackled the task representing data in CM1, and the official instructions for this level devote an entire section to it. You can see here I did a rough translation. Yet, items regarding data representation are particularly underperformed by French pupils. In fact, the overall average underachievement of French pupils compared to OECD countries is more than 8 points. For data representation, it is more than 13 points. Therefore, I guess to no one's surprise, being included in the official instructions is not enough to be mastered by pupils because there are other factors at stake. Let me give you just one example. It's not about statistical analysis, it's just so you can see what I'm talking about. Let's consider the task on the left. It's a Teams item I'm allowed to share with you. It seems quite ambitious because to answer correctly, pupils must analyze the proportion of each kind of vegetable with a part-to-whole comparison, and then have to choose the pie that correctly translates the information given by text. In other words, pupils need to take some initiative and to add intermediary steps which are not explicitly written in the instructions. In comparison, here is a question I took from a French textbook, also about data representation on the right. Here, the only things that a pupils need to do to answer correctly is to read the chart. She doesn't need to, for example, change scales. You can see why and how it is easier to answer this question than the Teams item. In general, and without being too technical, French textbooks tend to proportionally have less evaluative tasks that require the pupil to take some initiative than the Teams questionnaire. Nonetheless, the approach based on the official instructions seems to raise a relevant question. Perhaps the French pupils are simply at loss when faced with the Teams items because what they are being asked to do differs too much from the tasks they usually encounter in class. To try to compensate for the shortcomings of the approach based on the prescribed curriculum, we developed an approach based on the real curriculum. Beyond the official instructions, such an approach aims at determining what pupils are actually doing in mathematics class. However, on the scale that was ours, it would have been too costly in terms of human, financial, and time resources for us to carry out a study in the classrooms. We therefore chose to grasp mathematical activity through the proxy that are school textbooks, and that's why I'm here today. The question we try to answer within the following is the performance of pupils in the team survey linked to a lack of familiarity with the items making up the IA questionnaire? More precisely, are the pupils' performances attributable to the existence of a distance between the activity induced by the evaluative tasks in math textbooks they use in class and the mathematical activity they need to use to correctly answer the team's items? To answer these questions, we first had to define what it means for a pupil to be familiar with a task. Since, to our knowledge, no work based on the analysis of evaluative tasks offered by school textbooks have been undertaken yet, we had to define a familiarity indicator from scratch. And this factor is quite obviously region-dependent because each region has its own textbooks. We therefore constructed an a priori didactic analysis grid to compute a familiarity factor for each team's item and for each region by comparing the item to the tasks in the region textbooks. We assembled a whole range of idea, concept, and author, as well as personal experiences. We do not really have the time in this presentation to develop the content of this analysis grid, but I can still give you a few examples. So we were interested in the content of the item. So is it about geometry or arithmetic? Its cognitive domain, is it about simply knowing facts or solving a problem? We were also interested in the way the item was presented, so the length of the text, the need to articulate different information mode, and so on. As for our corpus, our watchword was accessibility, whether because we spoke the language or because the textbooks were available in bookshops or libraries. We analyzed textbooks from France, England, Ireland, Germany, and Austria. While the French textbooks were as representative as possible, the small number of foreign textbooks selected, 1 or 2 per region, meant that the international comparative study we conducted was exploratory from the start. At the end of the day, we still had more than 6,200 tasks to analyze, roughly with 20 indicators each, completing the database by hand. We chose in this thesis to use one statistical tool, which is multilinear regression. After analyzing our data, we only kept French and English textbooks because for other regions, the mathematical validity conditions allowing us to conclude something from our data were not met. It would have been possible to use other statistical methods, but learning how to use them was too time-consuming for a master's thesis. It was quite disappointing for us, but we still had interesting results, and today I'm just going to focus on one of them. Pupil score on a given team's item can be explained by didactic criteria relating to the item, which are therefore not subject to variation across region. For instance, the fact that the pupil has to articulate textual and pictorial information to correctly answer the item doesn't depend on any context. It doesn't matter if the pupil is French or English. You can see an example here on the right of the screen. The only way you can answer the question is by looking at the picture. But pupil score can also be explained by the familiarity factor we defined, which is itself subject to variation across territories. It quantifies how familiar pupils are from a region are with the team's items. Statistical tests showed that it is more interesting in both the French and English cases to consider models combining familiarity and the criteria for a priori didactic analysis grade of items than to consider models including only one or the other. This improvement in the quality of models can be seen in 2 indicators. Either the explanatory power of the model is higher, which is what happens in the French case, or the model is more parsimonious, which means that it uses fewer variables for as much explanatory power, which is what happens in the English case. Once again, as interesting as it is, what I presented is an exploratory study that doesn't claim to prove anything. Our goal was not to come up with a universal model, but rather to propose a didactically and statistically justified local interpretation of the results of the team's survey. I simply think that a new approach based on school textbooks deserves to be given more attention and might be worth exploring further. That's it for me. Thank you very much for your attention, and thank you once again for having me today.